Everyone, how you doing? Little late again. My fault, because we were talking.
Mhm.
So, Dr. Albers, how are you?
I'm very well, thank you, Wayne. And how are you?
I am delightful, thank you. I'm enjoying
Good.
life immensely. uh,
That's wonderful to hear.
yeah. It's so I hear that winter has returned to your part of the country.
Unfortunately, we had such a beautiful weekend. It was so warm. It felt like spring had finally arrived. And then today it was raining and cold again. It was horrible.
Well, I could quote again. We were talking before, and how does the
Yeah.
great poet say that this is the winter of our despair? But actually, it's spring. So, I mean, all is
Yeah.
supposed to be renewed. Well, you know, if the way they keep spoon feeding us, I think they've gone from the dropper now to where they're spoon feeding us, that things are changing to our planet, things are changing to our solar system, and we're seeing more and more of evidence that, well, it's not quite what we thought.
No, I think the only constant in the universe is change, actually.
You know what? I think that is something universal that everyone can agree to. All right, everyone. So let's join hands. This is a
Uh-huh.
kumbaya moment because we can say change is the absolute only constant. Hey, I just want to say hello to everyone in the chat room. Well, it's full. It really is. Claudia, you bring a
Wonderful.
crowd. We just want to say hello and we appreciate everyone coming in. So I was thinking, as you and I communicate during the week, I sent you an email
Mhm.
and about the odd phenomenon that we saw early, well, I guess it was mid last week, where we
Mhm.
actually had an equator coronal hole that looked to be almost, well, we know it was continuous on the Earth side. Um,
Mm.
Pretty odd, wasn't that?
It was actually. Thank you for that one. I actually wrote an article that addressed that.
I happen to have
Um,
that article pulled up.
yeah.
You see, this is what happens when you have to be the pilot. You have to see this and be ready. But no, I actually did. And allow me to pull this up, okay? Because I found that
Mhm.
to be very interesting.
Yeah.
Um, was that the one that said the stellar cores drawing energy? Which one was that? Was it 207 or
Yeah,
2?
I think that. Oh, I've written so many.
I
I'll have to
know.
check myself.
Let me have 1 second here. I think this
I
was
think it is 204.
204.
I think so. Where is my 204? There it
Do,
is.
do, 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 do,
No,
do.
no, no. That's the one on UVC.
Correct.
Uh, that's the UVC radiation. So it must be one before that, either 202 or 203. My
I think it's
goodness.
202.
Okay.
I do believe. Yes. All right. So allow me, ladies and gentlemen. You think we were flying blind, huh? I think it's this one right here.
Oh, yes, that's the one.
Yes. So, you know, Claudia, when you pull these up and we begin to look at
Mhm.
them, and I think this is what, the 197 or 193 angstroms?
That's the 211.
211. Okay.
Mm.
And I think it just shows clearer than any other the light spectrums what's really going on here.
Mm.
So what
Yeah,
was
well, I again showed this is actually why NASA got me to leave the university. It was about this. They're always very upset when I address this. But it's gotten to the point where if a troll leaves a comment, a really bad comment under one of my videos, I ask them to explain why the corona shrinks back during the SDO eclipse season. And I go as far as to say, and perhaps you can ask those legitimate scientists, whatever they want to call them, because at NASA, to help you answer the question, because they have no answer for this. This is irrefutable. Shows that the sun's going dark. It's not an eclipse. You can clearly see that. I explained this many times.
Yes,
but
yes.
If I ever get a chance to ask NASA face-to-face a question, that's the question I will ask them. Explain this.
Well, I don't know if I've heard an adequate explanation for coronal holes. I mean, if
the coronal hole, yeah. Well, they will say it's natural. The sun just creates coronal holes. But the fact that, as you mentioned, that coronal hole is opening up around the equator. Basically, the front of the sun is opening up into one large coronal hole, and especially around the equator. And this is because it keeps being weakened because the stellar cores are drawing energy from it. So what happened first? We had the appearance of a permanent coronal hole at the South Pole, then the North Pole, or basically around the same time. Now we have basically the equator starting to become or turn into a permanent coronal hole. I mean, how is that natural? How is that normal for a star to have a permanent coronal hole at its equator? It's not normal. The sun is basically becoming one large coronal hole because the stellar cores are weakening it, and it's going dark. And I show in this, I did another one where I showed that the sun goes partially dark in every single wavelength, including visible light.
Yeah, I'm trying to pull it.
So yeah. Here's again, I love to use this one because it's striped and you can clearly see there's an object there. So again, how would NASA answer the question? What do you think that is? It's clearly a spherical object, very large in the sun's corona. What do you think that is? It's one of your own images.
Yeah, they try to say that this is a magnetic cavitation, and
but it's striped, and the stripes are
it is striped. Well, there's your problem. Damn stripes again. You always got to be throwing in those facts, don't confuse us with the facts.
So
I'm sorry. It becomes to the point, and we'll drop out here for a second because I want to come back. I want to show. Give me 1 second, please. There we go. So I'm going to give me a second. I'm going to pull up SDO for us, Claudia, and give me 1 second on that. And there we go. Because I contend that, here we go. So let me pull this up in the 211. I think this is the latest one. Here we go. So
yes, the 211, you can always see what's happening to the corona more clearly because it shows
here we go.
A larger portion of the corona. Look at this. It's unbelievable that we now have all the time a huge coronal hole around the sun's equator. It actually goes quite far up and down in both hemispheres. And also, do you see on the sides how short the corona is?
Well, here it's virtually non-existent in the northern hemisphere.
Exactly. But that's been there for a while. We have a permanent coronal hole at the North Pole, a permanent coronal hole at the South Pole. It's been like that for years. I think since 2014 or 2015 that we've had this. But now there's a coronal hole at the equator all the time.
Can you see that, Claudia?
Basically, yeah.
So I just pulled this up into Supermag. Look at this. Let's go down to the
There's
southern.
no corona there. There's hardly any corona left anywhere. We see it, it seems to be a bit thicker on the sides because we are seeing the surface of the sun from the side. So it seems denser that way. But it only seems to be when it turns towards Earth, we see that there is actually not much corona there at all. It's just that we're seeing it on edge when we're looking at the edge of the sun.
So, as a layman, when I look at this, I'm asking myself, okay, why do we see such a reduction at the poles? But if we have fusion, right? That's what the sun does, right? It's fusion, right?
Mm-hmm. It is on the surface.
Yes. That would be almost like gravity. It would seem like you would have a constant regardless whether you were in the northern part of the sun or the southern hemisphere of the sun. It seemed like it would.
Well, the thing is, when it goes towards solar minimum, most of the activity is usually around the equator. So it is normal to have a smaller corona at the north and the south pole. During solar minimum. So that they will say it's normal.
Okay.
And but the problem is if you compare the sun now with what it was like close to the last solar minimum, you'll see that it's much, much worse. That it didn't have this kind of permanent coronal hole. It just had a smaller corona at the north and the south pole, not permanent coronal holes in the last close to the last solar minimum. But now, how do you explain a coronal hole at the equator permanently? That's impossible. If the sun was recovering it was moving towards a solar minimum, and then it's supposed to then recover. But it's never supposed to have a permanent coronal hole at the equator. That's ridiculous. That is absolutely not normal. It's not ever supposed to do that, but it's doing it.
So I saw something today when I had to change a light bulb. I watched the light bulb as you could see it began to arc on the tungsten. And as I was watching this, it was growing dimmer and dimmer, and then it got real bright, and then it went out. And I thought about when you were just explaining this, that what a strange metaphor that I could almost see the same thing going with a light bulb with what you just described with the sun.
Exactly. The thing is, the sun is electrical. This is what I discovered in the beginning. And I knew it was electrical because it was going dark. How can a star go dark from one moment to the next? Only if it's just losing its power, just like the light bulb goes out because it's lost its connection to the power source. In other words, there was a break in the circuit.
Yes.
The same thing is happening in the sun. That's the only possibility, that it's an electrical power system powering the sun. And when it interacts in a certain way with another object, its power source is disconnected and it goes dark. That's how I knew it was electrical. It cannot be thermonuclear reactions from its core, because if it was thermonuclear reactions, there would be light coming from the sun's interior all the time, and it would be impossible for it to go dark. And this is why NASA fights this truth with everything they have, because everything we know about how stars work, how stars form, breaks down when you realize the sun can go dark from one moment to the next, and it's powered electrically. There is a potential difference between the core and the outer layer, just like two electrodes. The core is one electrode, the outer layer is another. There's a potential difference across, just like with a light bulb.
Yes.
And that potential difference causes these discharges to occur, like lightning discharges. And this is how light is formed. And this is what causes fusion in the sun's atmosphere.
Someone was asking in the chat room, am I the only one that's not noticing that the sun is flickering? What do you think on that?
The sun is flickering because the discharging is slowing down. The discharging was so heavy before that it didn't look like there was discharging. It was just like a continuous emission of light because the frequency of the discharges was just too intense for us to notice that. Now, when you watch the 48-hour videos that they make available on the SDO website.
Yeah, I'll pull that up.
In the 3 or 4 images, you can actually see the flickering. You can see the flashes of the lightning going on in the sun's atmosphere because it slowed down because the sun's power is going down as the stellar cores drain it.
I'm pulling that 48-hour video up. Here we go. Let me stop it. So let me share
what I find surprising, Wayne, is that no solar scientist seems to be addressing this or even seeing what's going on with the sun, or even if they do, they dare not mention it. What is wrong with these people? Don't they have eyes to see what is going on with the sun? It's unbelievable to me that no one's noticed. Well, if like I said, they have. They
look at this. I mean, when you get the 48-hour view of it, I mean, the gaping holes. I mean, every time I look at this, I think of the philosopher that talks on at length of the great abyss. And, that's just a maul that I see of a maelstrom. And, you can see a solar flare ejected there. Did you see that, Claudia?
Mm-hmm. Yeah.
Right up here, and it's got one right here, the lower flame. So don't know if that ejected. Go ahead.
The sun still has areas where there is some activity going on, and it's usually because there's a stellar core around there drawing matter from the sun. It's actually still causing some of this activity. That's why whenever we see a CME, we usually find a stellar core within it in the cactus images. They're actually not only draining the sun and making it go dark, they actually seem to be the cause of whatever activity we're still seeing on the sun most of the time.
I just looked down here in the southern polar region, and it just, I mean, wow, it's just amazing.
Yeah, and you can actually see the little flickering here and there.
Yeah, that's what we were talking about. That's what. Now, I've had people send me videos of, clearly you can see that there is something going on with the sun. Now, I question as well as, and I'm looking on this on my very large monitor, the solar shield. Could that also be what some people are recording in the intensity of the light, where you almost, my background in the video post-production, we did a live shoots. We used to do, the company I was with, we did the Masters each year, and then we would do concerts. And so the point that I'm getting is that when you bring in artificial lights, the thing about cameras is that they can pick up when the light is actually growing brighter or less. And that's due what we call dirty power. There's a power spike, and then the light's going to amplify. That's what I relate to when I see what's going on with the sun.
Yeah, I mean, its power is fluctuating as it gets weaker, basically. Yes, definitely. Now, the thing is, that does not mean that the sun is not able to still have a strong CME or even an X-class flare.
Right.
These stellar cores can provoke it into having one of these. And if it's Earth-facing, it will affect us enormously because Our magnetosphere is a lot weaker than it used to be years ago. And it's weaker because the solar wind has died down. And the solar wind is actually what magnifies our magnetic field because it comes from trapped particles that come from the sun. And because we are getting less particles coming in because the solar wind has died down, our magnetosphere is weaker.
Yes.
And that means it's also not as able to withstand any increased activity that might occur from the sun, and it might occur suddenly.
When you say, you know, because we're seeing the evidence that the sun is growing weaker, I mean, I kind of relate it to if I had, for instance, a bulletproof vest that I was depending on saving my life, the equating that I'm getting is that I wouldn't depend upon that vest if it was the sun, right?
Mm-hmm.
Because it's obviously weaker, compromised.
Definitely.
Yeah, most definitely.
I mean, it's more and more obvious that what's happening with it is that it is dying. I mean, we can see it clearly. What I don't understand is why any of the solar scientists are saying it. They all seem to say, oh, everything's normal, everything's fine. The sun is just fine. We close to solar minimum. That's it.
Yeah, we're in a deep solar minimum.
Is not supposed to create a permanent coronal hole at the equator. I mean, where did they learn something like that?
I mean, I listen, I was involved. I was watching the sun with my telescope back in the 60s. And what most people don't understand is that, and I'll tell the story again, we did not know of anything called a coronal hole until 1974. And that was because of Skylab. They took up an X-ray camera, and it was an afterthought experiment. I mean, the damn thing weighed, Claudia, they said the thing almost weighed 500 pounds. And they they put it on the edge on a table and just aimed it at the sun. And and here's the odd thing about it. The astronauts on Skylab never knew what they were recording. When they sent the film back down, because it was film, folks, film, and when they got back down, they started processing, and they didn't know, NASA didn't know what it was looking at. Are you ready for this, folks? Astrophysicists did not know what they were looking at. You had the best minds trying to figure out what was wrong. What was this? And here's the thing that I know your research is spot on. My dad worked for NASA for many, many years. And the point is this. When they discovered they were small, Claudia, they were very random. And there were many times they didn't show up at all.
Mm-hmm.
Now here it is, 2018, and you've done the comparison work from 2011 to 2017 to 2018, excuse me. It's a clear diminishing, and they're growing. It's like a cancer. It reminds me of a melanoma that's on a person's arm, and you just want to ignore it. You just want to say, oh, it's just a mole. And then you look down, and the thing starts taking over most of your arm.
Mm-hmm. That's right.
See? I'll defend you.
It's clear. I mean, that's very interesting that your father actually worked for NASA, that you were there when they were starting to learn about coronal holes. Oh. And I'm sure even when they were tiny, because the stellar cores in 1974, there were stellar cores here already. I actually have some images from one of the old satellites where there were small stellar cores in the sun then, I think from the 1980s or even before then, 1970s. And so, I'm not sure anymore if it was the 1970s. I must look at that. But I wrote an article. It was a C1. It was a coronagraph image images that they were taking, and yet you could see little stellar cores, little holes in the corona. They were there already.
So connect the dots, folks. So what she's talking about, core 1, core 2, that was some of the, we still get the images from them. I mean, they've gotten beat up, core 1 particularly.
Yeah.
You know why we sent core 1 up? Because of Skylab. It was like, holy crap, what's happening to the sun? And this is what most people don't understand. The knowledge that we have gained on this star is really in the last 2 decades that you could say that the science began to catch up with what the observation was. I said that's profound.
That is profound indeed, Wayne. Yeah.
There's your philosophy for the night.
We haven't had the technology to really observe the sun for very long, actually.
No, we haven't.
So we started observing it when it was already being affected by the stellar cores. So what we've come up with, what we started seeing then was already probably the effects of the stellar cores on it.
Yes.
The tiny coronal holes. And then they came up with all sorts of terms, because I'm sure they figured out what was going on quite soon, but they decided to hide it from the rest of the population. Can you imagine if the whole population on Earth had figured out that the sun was dying in the 1970s?
We'd all been stoned right now. We wouldn't have done anything, Claudia. I don't know on your side, but I'm just saying that people would have known that. It's, yeah.
Yeah, also, sorry.
Go ahead. No, go ahead. No, go ahead.
Yeah, also, people would demand of their governments that they do something to help them. And instead, people were kept in the dark so that whoever was in government could make plans to help themselves and leave everybody else in the dark.
Oh, isn't that the truth? And, I often wonder what the Russians know, what the Chinese know, because, hi, Suji, how you doing? Here's the thing that gets me. We get so dependent that we think everything is either NASA or jet propulsion, et cetera, et cetera. But allow me, this is a perfect segue, Claudia. I had this pulled up because I wanted to get your thought on this. 2 things. Here, China plans to grow flowers and silkworms on the dark side of the moon. Okay, you know what immediately hit me about this article? If they're going to be growing, they're actually putting a station or something there, it tells me that they've already done the exploration to set that up. So what does the Chinese know about the dark side of the moon?
I don't know, but as far as I know, there are quite a few bases there.
Yeah, they have, haven't they? Well, this is what got me. They want to create mini biospheres on the dark side of the moon. And I thought to myself, well, now, wait a minute. When you start exploration, you don't just simply say, well, let's just go ahead and send someone up there. Let's see how it works out. It doesn't work that way. So I just thought that one was very odd, that apparently the point is that we so often think that it either has to come from NASA. And I think that there's a whole realm of information, Claudia, that China has that we have no idea. I don't know if our scientists know.
Yeah. The thing is, Wayne, about the moon, isn't it strange that there is no satellite orbiting the moon? If the moon was really empty, wouldn't you put a satellite orbiting the moon? If they're observing the sun, why wouldn't we want to observe the moon and what's going on there?
I don't know.
There's nothing to show us what's going on there. The same thing with Mars. Why isn't a satellite in orbit around Mars showing us what's going on there all the time? It's definitely within our technological abilities to have that. And we like to observe the sun. Why can't we observe what's going on the other planets? Well, the reason is because they have built bases on there. And there are probably human bases, probably alien bases all over the place, and they don't want us to know about it or what they are doing.
I will say this. I know astronauts. I know one that recently passed on. He actually passed on last year.
Mm-hmm.
His question to me was, he says, why did we not go back? And that was the question he often told me. Now, he said, we did go back. In the Apollo program, Congress bought and paid ahead of time and built 20 Saturn V rockets. So what happened to them? What people don't realize was that, Claudia, there were complete modules. There were new experiments that were completely ready. The advancement we had made by the time we had gotten to Apollo 17 was that we were now having rovers go over the moon's surface. We were able to travel some 10, 12, 15 miles on the surface of the moon. And you're right. Why'd we stop? I don't think we did.
To tell you the truth, Wayne, I find it hard to believe that we went to the moon in those little ships that were not electromagnetically shielded. Because the only way to get out is through the poles. Otherwise, you're going through the Van Allen's belt, and the radiation. I mean, those ships were not electromagnetically shielded. The astronauts should have died.
Well, I know that they were gold shielded. My dad he designed all the instrumentation panels. He got there in Gemini, and he retired back about 5 years ago. So, I know a lot of people don't think we did, but, the laser experiment alone tells us that we know exactly precisely where Apollo 15 put that laser reflector at. And you can go and get your high-powered laser, and they'll give you the coordinates, and you can actually measure it coming back. But I don't know. The moon is always one of those mystery things. How about this one?
I think I've seen so many images where you see ruins on the moon and ships, and it is just so much out there, Wayne. And I would think they wouldn't want us to know what's there. That's what it is.
I've never had anyone explain to me, Claudia, how that moon stays where it stays. It doesn't rotate. How it generates a gravitational field around itself. And if it's perfectly balanced between the sun and the earth, my question is does that stay constant? I don't know.
Yeah, well, the moon does rotate, but its rotational period is the same as its orbital period, so that as it rotates at the same time as it goes around, so it always shows the same side towards the Earth. It's very strange. I mean, if I wanted to hide something and put it on the moon, that's what I would do. I put everything on the dark side and make sure that the moon orbits in such a way so that it's never seen from the surface of the Earth.
It's wild. One of the things I know that while we did go up there, one of the things that they learned from the first expedition was this, when Neil Armstrong went out, was that the surface of the moon, the dust is actually, it's sharper than glass. And what they found out very quickly was that the material that they had began to disintegrate. And that was a real problem in the craft, because this moon dust is razor sharp, and it literally cut through everything that they had. Wow. Yeah, pretty weird.
That is weird.
So that's why I know we went up there, because
Okay.
Gene Cernan, that he was the last commander of Apollo 17. I had the privilege of flying back from Orlando to Houston with him, and we were in first class, and he was in seat 1B. I was in seat 1A, and we had a delightful conversation.
Okay.
Yeah, I asked him. I said, "So, what was it like when you stepped out?" You know what he told me? He said, "I felt God." He said that there is a presence. He said that was tangible. He said, here's the thing. I said, so what did the heavens look like? He said, oddly enough, he says, you can't see the stars. He says, you can see the very bright ones, but he said, when you're on the moon, when you're in the daytime, he said, you can't see the stars because the dust of the moon is so reflective in its content that he says it blocks out everything. So anyway, and he was already pretty well aged when I was talking to him, but he never did answer me the question, how does it stay up there? He never did. So Claudia.
Yeah, well, yes.
Okay. I wanted to see what you thought of this because this is strange. So they're saying up in the atmosphere, our atmosphere, which begins to say about maybe potentially Venus, this is why I'm bringing this up, that there is literally trillions of viruses that are in our atmosphere that are basically raining down on us, and apparently it's coming from outside.
Well, I doubt that. To tell you the truth, I think these viruses are coming from the chemtrails, and they putting them up there, and then they come up with some story about it coming from outer space.
You see, that's why I pulled it up.
The thing is, we have the Van Allen's belt. Anything that goes through the Van Allen's belt is killed by the radiation. What kind of virus is going to survive that? It doesn't make any sense. It just doesn't make any sense.
Explain to people where the Van Allen belt actually is in the Earth's atmosphere. I mean, this is a question that has pondered many people, is to...
Yeah, well, it's basically a trap. It's like a toroid or a donut-shaped ring outside the Earth's atmosphere. The inner ring is protons, and the outer ring, it's even larger, is electrons. These are high energy particles that come from the sun in the solar wind and then are trapped in these belts by the Earth's magnetic field. But they're very high energy particles. Anything going through them will be impacted by these particles. Very fast moving electrons will destroy circuitry, will destroy cells inside the body. The same thing for the protons. And so it's just, and it's a thick layer. It basically forms these rings. If this was the Earth, there would be a proton ring around here and then an electron ring like that. And some people even say there may be more rings as we move further out. It may change depending on how much radiation is coming in. As radiation comes in, the belts fill up with more and more particles.
And that's why our Skylab is actually in our atmosphere. I mean, the International Space Station is actually in our atmosphere, below our atmosphere, in fact.
It is. It's in a low Earth orbit. It's about 240 miles from the surface of the Earth. It's not very high up.
No, it's not. Where I live in Denver, Claudia, we see it regularly. We're in what they call the footprint. So every 6 days, it comes through, and for the next 3 days, we get to see it. And I have a regular schedule that alerts me to it. And it's quite beautiful when you see it go over. I mean, it's very bright, really bright. I saw this and I wanted to bring this up to you. This was, had made the web everywhere. The guy that was on the plane in Texas and was in a thunderstorm. And I wanted to bring this up to you because to me, this reminded me of plasma, a discharge, then something happening as a result of a lightning discharge.
Yeah, the thing is, they have these high-powered lasers. You can actually make a connection through the laser beam from the Earth's ionosphere to any other of these satellites they have in orbit. They can actually power them directly from the ionosphere that way. So it may be the powering systems for the satellites. They must have a lot of satellites in orbit and a lot of devices in low Earth orbit in order for them to be able to hide what's actually going on. I just watched a video by JFP where he clearly shows that the moon is being simulated, which I knew. It has to be simulated, Wayne, because if the sun is going dark periodically, and we know that's occurring, then the moon would just disappear because the moon only reflects light from the sun. So they have to simulate it. The same thing for the planets. They have to use holographic projections, whatever in the sky. But they make mistakes with it all the time because you can see in JFP's video how the moon goes from being a crescent to being a full moon to being a crescent again.
Mm-hmm.
So that clearly shows it's not the real moon. There's no way the moon can change from being a crescent to being a full moon in the same night.
Oh, in the same night. Well, that's quite remarkable if it's happening in the same night. I would agree with you. That would be quite, there is so much going on that it's hard. It attacks the consciousness, and cognitive dissonance sets in that, when you begin to get into a position where you don't know what to trust. And particularly when you begin to question your eyes, what you're seeing. I think that's part of this mind coitus that they got the planet into, because there's something going on. There's no doubt about it.
Clearly, there has to be something going on because things do not make sense. But
no, they don't.
The thing is, what happens with most physicists is they have grabbed onto their theories to the point where they will not consider what they see with their own eyes as the truth. The thing is, we have to realize that if we see something that doesn't make sense, then we have to figure out what is causing that. And not just say, no, but the theory says that's impossible, so I didn't see that. It doesn't work that way. If we are seeing something, we are making an observation. We have to at least look and think about it. Like with the sun is opening up in the equator with a coronal hole. What are we going to do? Oh, there's no way the sun could be going dark, so let's ignore that. That's what they are doing. You can see it.
Yep. Well, I hear it all the time that, it's impossible for the sun to be diminishing and, we can mark the solar wind. But I tell people all the time, you look at that solar wind telemetry. And if you're telling me that when we start seeing it flatline, that there isn't something going on, I mean, you just have to, I listen to other channels and how they begin to try to explain it, but I am also an observer and I can look at it. And when I see the solar wind drop below 300,000 kilometers per second, that's slow, folks. That is really... It is. Go ahead, Claudia.
Yeah, especially since we have coronal holes permanently facing the Earth. What are we supposed to get? Fast solar wind all the time. We used to, but we don't anymore. We're getting extremely slow solar wind whilst we are facing coronal holes on the sun. I mean, that is ridiculous.
It's wild, because I'm looking at this going, okay, sure. Now, I was out today, Claudia, and I want to pull up your paper because I think this is going to be very important for us this summer here in the Northern Hemisphere. Let me pull up, as he says, I'm looking for it. Oh, here it is.
The one on UV radiation.
Yes, ma'am. Yes, ma'am.
Yes, I think this is amazing. I read this article, and Mr. MBB 333 is the one who first talked about this. And he says, oh, it's a peer-reviewed paper. And I said, yeah, it's peer-reviewed. That's why they have made absolutely wrong conclusions. They put in the right data. Okay, they've measured something. They measured the UVA, which is the low energy UV radiation, the UVB, which is mid-range for what we're supposed to get here on Earth, and the UVC that we're never supposed to get on the ground. As you can see, the curve goes straight up between about 280 and 200.
Yes.
Nanometers. So from the middle, the UVB towards the UVC. So going from right to left. Okay, it goes. Go further towards the left, and you see it goes up there. That's where it's highest energy, and it's the most damaging to the human body. And it goes straight up like that. Look at that trend going up. So they measured this, and they measured this, I think it was June 2017 and January 2018, 2 measurements. As you can see, they correlate very well with each other. So it's clearly they made a good measurement. And then if we move down to the next graph, they actually compare with an earlier measurement that was done by someone else. And here I just mentioned that we're not supposed to get any UVC, maybe between 1% and 3%, that's all, because the ozone layer, which is the ozone layer absorbs UVC radiation.
Right here.
Okay? Yeah.
That's when they made a big deal in the 70s about the hole in the atmosphere, the ozone, right?
Mm-hmm.
Okay.
Yeah, even with the hole, we weren't supposed to get much UVC radiation. There's the ozone layer. So it's between about 12 and 20 kilometers altitude.
Okay.
So from about 35,000 feet, something like that.
That's why I don't like flying anymore.
Yeah. So So our ozone layer is supposed to be getting thinner. The chemtrails are definitely damaging the ozone layer. So we're supposed to be getting more UV radiation coming through and getting to the surface of the Earth. However, a measurement was done in 2002. And here we are. You see the measurement is that straight line that starts just below 300, goes straight up. As you can see, it ends with UVB. There was no UVC measured at all. It stops in the middle of the UVB range.
Why did they stop the UVC?
Because it wasn't getting through. There was no UVC measured at the surface. This is a surface measurement.
Okay.
There was none. This was from 2002, and they measured 0. Nothing. You see, from the higher energy UVB wasn't there either. Only the low range UVB was measured at the surface, and then the UVA, which we're supposed to get anyway. It helps us produce vitamin D, and it's actually healthy. So that's what they measured, and they compare it, fine. Okay, this means that now we are getting UVC radiation that we were not getting in 2002. And then they show us this graph. Do you know what that greenish wiggly line is? It's what NASA measured above the atmosphere that was coming from the sun. So before it goes through the ozone layer and before the ozone layer can filter it, this is what's getting to the Earth from the sun. But notice that the measurement on the left side for UVC is higher than this.
Yeah.
How can we get on the surface more UVC radiation that then is coming from the sun? The only conclusion is there is a source within the atmosphere. It's the only logical conclusion. But what did the authors conclude? Oh, their conclusion was just that they've always assumed that UVC does not get to the surface, and that's wrong. This is the conclusion they made when they clearly showed with their graphs that, first of all, we're getting UVC we were not getting before. And second of all, we're getting more UVC than the sun is producing. So there has to be another source, and the source is in the atmosphere. But they could not make a logical conclusion based on their measurements because it was a peer-reviewed paper. And that's the only way they could get it published.
So what could cause the radiation in our atmosphere? I mean, you know, I firmly believe that our DNA is being rewritten, programmed. I have others that write me. The evidence is there. I know when I stepped out even today and all winter, when the sun was out, there were times where it literally burns your skin. And
yeah, the reason why, Wayne, is because there are sources of UVC radiation in our atmosphere. I've written plenty of papers showing that how light rays coming through clouds, how they diverge. And therefore, the source has to be in the atmosphere. What is the source? It's the sun simulators. They're using sun simulators within the atmosphere. How would we otherwise not notice that the sun goes dark? They're actually illuminating the atmosphere so that the sky looks blue. But if you look at the sky carefully, it doesn't have the same depth that it used to have many years ago. It's like it's shallow.
Think people, yeah, I agree with you, Claudia. I think what the point is, I don't think most people know that or even remember it. And particularly millennials below, they don't know what the sky looked like prior to 1990, 2000. You know, they look at us, you know, I still see myself as, you know, anyway, it doesn't matter. But the point is that we saw a different sky growing up than what's out here today.
Definitely. And this is clear evidence based on good measurements that there is a source of UVC radiation within the Earth's atmosphere. It's below the ozone layer. This is the only possible explanation. And this indicates that there are sun simulators within the Earth's atmosphere that are illuminating the atmosphere. And this is why, you see, they are reproducing the sun. But the sun's supposed to be outside the atmosphere, and that sunlight is supposed to be filtered by the ozone layer. But now what did they do? They took a light source, they placing it within the atmosphere because they cannot make it as strong as the sun, but yet it's producing extreme ultraviolet radiation. The way that curve goes up, I would say it's not even just producing UVC. It's obviously also producing extreme ultraviolet, may even be producing X-rays. We are in trouble. This is why your skin feels like it's being burnt immediately when you expose it to this artificial sunlight.
So, you know, I go out and it's just it's a good one. It tells me what the UV, A, envy. I don't have the C, and I'm telling you, I'm looking at this, but because, when I was 10 years old, 11 years old, we were not wealthy, and we grew most of our food. We had an acre garden. My brother and I weeded that garden every day from sun up to sundown. Now, I had the best tan and my hair bleached out white.
Yes.
I could not do that today. I would not put a child out there in this sun today. And I can tell you, I'm measuring it now, Claudia. The intensity starts turning on about right past the 10 o'clock hour. And you go out there at 11 o'clock to 1 o'clock, that sun hurts. It stings.
Mm-hmm.
And I get emails from others that they seem to think about that same period of time is when we're getting the most of those effects. This is disturbing. This is cancer. This is genetic, destroying DNA, chromosomes. I don't know what else it's doing to us, but I know this: humans are not supposed to be around radiation.
It's also destroying our food supply, because
Bingo.
the kind of UVC radiation that we are heating plant life with actually stops photosynthesis. And this is probably why we may be seeing the size of fruits and vegetables decreasing, because they are being affected by the UVC radiation. Eventually, we'll have to grow our vegetables in hothouses only. They cannot be exposed or be outside. Because, of course, some plastic or glass will filter most of the UV radiation.
Yeah, we're seeing it up here in Colorado already. I mean, I love growing tomatoes. I love that. I love growing different herbs and what have you, but it's getting increasingly hard. This year, I am actually looking at putting a filter net over the plants because last year, the radiation burns on the plants, the tomatoes just got decimated, just decimated. Yeah. And, and they love sun, they love sun and et cetera, but yeah. So they're destroying the food supply. Soylent Green, do you remember the movie with Charleston Heston? Yeah. I think we're going to be looking at Soylent Red, Soylent Yellow, which is all of us. I mean, where's this going? I mean, you look at this and I don't know. I don't know if I often thought this, that they're going to start World War III because they have to in order to be the distraction of what's happening above us.
Yeah, it does things seem to be marching in that direction.
They do.
So, yeah.
And then you could blame it on, you could blame it on the Russians, blame it on the Chinese, they're messing with the atmosphere and then something happens. I think that this is, I don't think it's because of something else. I think it's because the world powers know that the proverbial feces is going to hit the fan.
Yes, I think so. Don't forget, they have a plan for depopulation.
Yeah.
They have Fukushima will destroy all life on Earth, but it's probably not fast enough for them.
No.
So they've destroyed the Pacific Ocean with it, but obviously to them, they haven't decreased the population enough. They've manufactured a lot of diseases, but it's not going fast enough. They're vaccinating people, but that's still not depopulating enough. So what's the only thing that will cause the kind of depopulation that they want? It's war.
War. What's it good for? Absolutely nothing.
Nothing but decreasing the population.
And that's what it is. It's the culling of the herd, Dr. Albers, is what it is. Yeah. And I've contended before that you look at humanity, and there have been great cullings. and it will take down the population. Stress of the planet becomes less. And if the Georgia Guidestones are any indication that 500 million seems to be the base number, I don't have that ticket. Do you? I didn't get a ticket that says, hey, come over here. You can actually, yeah, because I think that that's where it's heading.
The thing is, you don't want to live in the kind of world that they want anyway, because it may be worse to be alive than to be dead, because they will want people to be slaves and basically become an android controlled by a supercomputer.
Oddly enough, I don't have the story pulled up, Claudia, but in the UK, they are now voting to make robots, androids, sentient beings.
Mm-hmm.
The UK has approved the genetic modification of genetic material of humans now in the lab. We are rapidly advancing. And, you know, I had a video that's gone viral. And the thing that I contend to people is this, Claudia. We are seeing the evolution of our species right before our eyes. We're seeing the next version, and it's not going to be Homo sapien. I think it's going to be Homo technio something. But we're seeing the transformation of our very species before our eyes. And people are not listening. It's frightening to me. I see the studies. I see what Silicon Valley is doing. And now that I see world governments now taking off the restrictions of genetic manipulation, manipulating human DNA, where does this lead?
Yeah, it's not a good thing at all, I don't think. Basically, they're getting rid of free will.
They are, my dear. You know, that's why I appreciate our shows, is that, you know, free thought is still here. And I think that most people realize now that we're not looking to debate. We're not looking to, you know, come against a person's ideology, philosophy, or whatever. What we're trying to say is that maybe if we could come together as a group, which we have here, is to listen, observe, and you are the person that we look for where the mind is concerning, and and for me to open up the thought of going, okay, look at this. Listen, you know how many times I show your comparison? It's overwhelming. I had one person say, I don't know what to make of that. I said, well, you know, if I took a picture of your kid and, you know, took another picture of your kid and they were suddenly becoming more transparent, what would you think of that? He says, well, I don't know. And I started laughing and I said, Back to the Future. Anyway, you know, we're going to leave the classroom with everyone at least a smile on their face, because, you know, great knowledge. I love what the great philosophers have said. With great knowledge comes great pain. Is that not true, Claudia?
Yes. I must say that sometimes knowing more about what is going on gives you, in a way, a burden. It gives you a burden because you want to tell others about what's going on and warn them. And plus, you understand that what is actually going on is so bad.
Yeah.
And if you think about it a lot, it's, you know, it can make you very sad about what's going on.
It make you depressed.
And you want to do something about it. There's nothing we can do about it. We are not in control. So,
you know, I tell people, you live every day, you soak up every emotion, and you go on with your life. If there's a train wreck coming, there's nothing you can do. We're not driving the train.
Yeah.
And the thing is to love the people you're with, love them for what it is, learn to love yourself, learn to forgive yourself, learn to forgive others, and realize that I said this to someone who I love very, very much today, that in mankind's history, there have been calamities, disasters, some that have struck on a worldwide scale. But as I told this person, I said, here's the thing. There is something about our species that no matter how hard we're kicked, no matter how hard we're down, we always seem to rise again. And Claudia, whatever is coming, whatever is going to happen, I say this, we are a remarkable species.
Mm-hmm. Yes.
And that's where I lie my hope. And
yeah, well, I think you're right. There's something special about us because obviously God saw something in us that he saw that we were worth saving. And he basically decided that we needed help, and he did what he needed to do.
Yeah.
But to me, whenever I start thinking about what's going on, what it does to me is it drives me to search for a spiritual connection with the Creator.
Yes.
Because I am powerless to change things, but he's not.
Yeah. You see, a lot of people, I happen to agree with you. This journey of mine has brought me to a greater understanding of the Creator.
Yes.
I've learned something. Life is immortal. Life will never stop. And the more we look into the cosmos, the more we're understanding that there is something yet out there.
Yeah.
Yeah.
And my discovery that the whole universe is made out of light. Isn't that amazing? I mean, even though I'm a Christian and the Bible says that God is light, and it says in Genesis, God first said, let there be light. I didn't start out thinking, okay, this is what the Bible says, so therefore that's how the universe is. I actually went through studying what's going on in the solar system, doing observations, thinking about it to get to that conclusion.
Yes.
And to me, it was surprising, but it agrees with what it says in the Bible. God is light, and he produced everything out of light.
Yeah, there's a whole philosophy built on that. And the fact that the light is in itself a separate creation within itself. Because as you remember, in the beginning was God, and then God said, let there be light. So the indication is that there was something before light.
Yeah, well, God, but then, you know, it says in the New Testament, God is light and there is no darkness in him whatsoever. So there's that in the New Testament. And then in Genesis, and I believe what he was doing in Genesis was not creating the universe then. He was recreating the earth or the solar system, whatever. So it was here already. It had become chaotic for some reason. And then he came and recreated the surface of the earth. And that's when he said, let there be light. So even the recreation was through light. So that's how I see it.
I will take Young Shelton's approach. The comedy series, Young Sheldon, when he was sitting in church, and the preacher said, in the beginning was God, and God said let there be light, and that, you know, God was light. Young Sheldon raised his hand up and said, so, sir, what you're saying is that God is a photon. We'll end it right there, folks. And I have to say, all hats off to young Sheldon, because I think he is right. If God is light, then God is a photon. It's by the definition
Yes.
of light. Now,
Mm-hmm.
that begins to open up a whole area, because as you know, Claudia, as long as you and I've known each other now for going into the couple of years now, we've known each other for a while, that photons are amazing things, are they not?
They are indeed. And
Yes, they are.
I actually discovered that they are light. They are the source of all particles in the universe, and they are energy, and they are heat. Particles that have heat and collide against each other, those photons within them, they exist within the particles and cause the particles to vibrate. And that's heat within the particles. And when they collide, the photons within these particles share with each other, flow across from one particle to another, so that they have the same amount of energy and the same amount of photons. So energy is not an abstract concept. Energy is a photon.
When we talk about that, my mind likes to go places, because for me, I see we haven't yet to discover, I think the full potential of the photon.
Mm-hmm.
I really do. I think that it's so
Yeah.
much more. Go ahead,
Yes.
Claudia.
And then there is the neutrino. Okay, the neutrino is what I've been thinking about lately. The neutrino to me seems like a form of a photon, but it's in a mass form. The photon energy can flow backwards and forwards. So it can turn into particles, and the particles can turn back into a photon. But a neutrino, once it's a neutrino, only with with huge difficulty will it turn back into particles.
Yes.
So basically, a neutrino is the mass form of energy. And when it's the mass form of energy, it hardly ever goes back into the photon or the energy, which is the massless form. So the mass form is actually a photon slowed down. So it's in a lower state, basically, of energy. And I think that's what the neutrino is. I'm still thinking about it, but basically a neutrino forms from a reaction where a neutron forms when an electron and a proton combine, and then forms a neutron, which is neutral. And it gives off a neutrino as well, which must be a form of energy. But because it has some mass, it's in a mass kind of energy. And this kind of mass may exist within particles because they come out of particles, but is not shared like the photon. The photon, like I said, they collide and the photon energy is shared. But the neutrino energy is not shared. So it may be a way that particles lose mass by losing neutrinos, because neutrinos have some mass. That's what I'm going to write. I'm going to write something about. I'm thinking about it.
I love that.
Yeah.
Well, because, on my whiteboard back there, it says that light is both a particle and a wave.
Yes, all particles are all matter. And a photon is a particle as well, even though it doesn't have mass. So everything can be explained in terms of a particle and can be explained in terms of a wave. Except the photon is a free particle, because wave associated with it can occupy the whole of space. Whilst for a particle, it's confined to a region of space.
You see, when I hear that, what I hear is that it is, but it is not. It's like a quirk.
Yeah.
How a quirk will come into our reality and then go back out.
Yeah, well, the quarks on are not observed at all. So to tell you the truth, we are
strictly
not
theoretical.
Yes.
Them
I mean,
bastards.
when I did my PhD, I used quarks. I mean, I used what's called quantum chromodynamics to work with the pion to see what it does, and that's what I used. I used that theory, but it doesn't mean that they actually exist. I haven't actually seen enough evidence to suggest that they do exist. Although it is possible, it's likely that particles do have internal structure. Whether it is 3 quarks in protons and 2 quarks in mesons, like the pion, well, that's what I used in my PhD, but I don't know.
I want to go into more.
Don't have the observations so that I can tell you emphatically that it is like that.
But the math works out, right?
Yeah, the math does work, up to a point.
Right.
Because you always end up with infinities, and you have to somehow work around them.
Do you make an exception to the standard, to the model that actually does the workaround? I mean, I'm sure we could talk about this forever.
The standard model, I always say, is like a dinosaur. It should be thrown out. The standard model, because it has so many parameters, and whenever they have one measurement that doesn't agree with the model, they tweak the parameters.
Of course they do.
I mean, that's really cheating, Wayne. It's really not a good theory.
I just wanted to know where you stood on the.
I'm a particle physicist, and I don't believe most of the theories that come out of particle physics. And I don't agree with the standard model. And I don't agree. It's based on the Big Bang as well. They're always trying to say, oh, we must compare what we're seeing now with what occurred at the Big Bang. And
I still don't understand how you get energy.
There was no Big Bang.
Yeah, I don't get how you get energy from nothing. But
exactly.
Well, we've gone way over on this one. This was fun.
Yes.
This was actually, I enjoy every time, Claudia. I look forward to Monday nights. They're one of my favorite nights.
Oh, that's wonderful.
Well, everyone, we've had a full room tonight. Wow, 111 thumbs up. Well, thank you, everyone, and no thumbs down. Wow. Well, that's very kind. Thank you all. Claudia, been fun. You have a great week. I'm sure
you too.
By the time we meet next Monday night, we're going to have another list.
I'm
sure. I'm really looking forward to your paper on neutrinos. I'm really looking forward to that. That's fascinating. Okay, everyone. Have a great week. We'll see you again real soon, one of the others, and I'll be posting some more. Claudia, I have you already in the permanent on your channel. Go and subscribe to Claudia. And Claudia, do you do live program streams on your channel?
No, Wayne. To tell you the truth, I'm not very good at that sort of thing. I do it with Scott because he's the driving force in that. But I'm way too shy to just do a live stream.
I would have never known that. To me, you're just perfectly comfortable as like two old friends just sitting having coffee.
Yes, but by myself, I just cannot make myself do it.
Okay.
I just can't.
Well, anyway, go over and subscribe to her and watch her videos. You learn something. You really will. I feel very fortunate because Claudia sends me her papers, and it's like eating chocolate. it's delicious.
Wonderful.
It is. All right, Dr. Albers, another thank you so much. And everyone, be kind to yourselves. Remember, it isn't worth getting yourself all wrapped around the axle about. Love the people you're with, love yourself, and we're going to make it through all this. All right. So, folks, we'll see you again real soon. All right, folks. Bye-bye.